Hello, this is exercise 3.2. I'm going to do some of the odd numbered problems down below. Before I get into it, though, I just wanted to do a quick review of the truth tables for the five logical operators. I kind of skipped over this or did it really quickly in the previous video and maybe confused some people. One of the functions of truth tables is to really define the five logical operators. That is, tell exactly what they are. So, for example, negation, the definition of negation is that a negation of a sentence flips the truth value, right? So you can show that with a truth table, right? So a truth table shows all the possible values. So for any sentence P, if you remember the principle of bivalence, has two possible values. It could be either true or false. This column here shows you what happens then if you negate P. If you start with a true sentence and you negate it, you get a false sentence. If you start with a false sentence and you negate it, you get a true sentence. All right. So notice with negation, since the operator only applies to single sentences, there's only two lines on the truth table because there's only two possible truth values. Oops. But now for the other four operators, these are all connectives, right? They connect two sentences. So that's why you need more lines in the truth table, because now you have to deal with possible combinations, right? So there's a hard and fast rule that I think I mentioned in one of the earlier videos, which is 2 to the n exponent, where, n would be the superscript here, equals number of lines on the truth table, whereas n equals distinct atomic sentences, right? So if you have, in this case, we have two, so start with negation, we have 1, right? So 2 to the first power equals 2, right? So we have two lines in the truth table. But now when we have two distinct sentences, P and Q, right, that's 2 to the second power, or 2 squared, which equals 4, of course. That means we need 4 lines on the truth table. 1, 2, 3, 4. Right? If you have 3 atomic sentences, 2 to the third power is 2 times 2 times 2. Right? That's what the exponent means, is how many times you multiply the number by itself. So 2 times 2 times 2 is 8. If you had 4 distinct atomic sentences, right, it'd be 2 times 2 times 2 times 2, which equals 16. So that's how you determine how many lines you need on a truth table. You count the number of distinct atomic sentences and raise 2 to that power. So if you look at, now 3.2, we're not doing full truth tables, but you can just see, so you have O, M, N, there's 3 distinct atomic sentences. So if we were to write out truth tables for these, we'd need 2 to the third power lines, which is 2 times 2 times 2, which is 8. So these would all be 8-line truth tables. But to define the connectives, again, we can do that with 2 sentences showing. So the disjunction, the definition of the disjunction is that it only comes out false if both disjuncts are false, right? And again, that's reflected in the truth table. If they're both true, it comes out true. TF, true. FT, true. But here on this last line, where both P and Q are false, the disjunction comes out false. So again, think of that as the definition for a disjunction. A disjunction is any sentence that only comes out false if both disjuncts are false. Conjunction is kind of the flip side of that. It only comes out true on one line, namely when both conjuncts are true, right? And I've been saying this sometimes when we're translating, how do you know if a sentence is a conjunction? Well, you have to ask if both of these, or if one of these came out false, would the whole sentence come out false? And if yes, it's not a conjunction, right? So a conjunction is a sentence such that both conjuncts have to be true for the whole thing to come out true. Otherwise, if you have one false, or both false, it comes out false. Conditional is kind of a strange truth table. Like, the disjunction and conjunction follow English usage pretty closely. Conditional does on the first two lines. If I say, if the Red Sox win the World Series, I'll pay you $100, and it's true the Red Sox win, and it's true that I pay you $100, then I said something true. If I say, if the Red Sox win, I'll pay you $1 million, and the Red Sox do win, but I fail to pay you, then I've said something false. Right? The last two lines where the antecedent comes out false, the conditional comes out true. And that's not real intuitive. If I said, if the Red Sox win, I'll pay you $1 million, and the Red Sox lose, well, I don't know. It's not real easy to say what we would say about the truth value of the whole sentence. But for now, the thing to know is that the conditional only comes out false on one line, namely if the antecedent's true and the consequence false. Otherwise, it comes out true. And this is one of the most common mistakes students make in logic, is they think if the antecedent's false, the conditional's false. But remember, false antecedent means true conditional. And then finally, the biconditional. Whoops, I just realized I copied and pasted this without fixing it. So the biconditional comes out true if they have the same truth value, false if they have different truth values. So the biconditional truth table should look like this. Stretch it out. So if they're both true, it comes out true. If they're both false, it comes out true. But if they have different truth values, it comes out false. All right, so those truth tables for the operators you need to know to do these kinds of problems, right? Because, and you also, the other thing you have to be able to do is identify the main operator, which I did talk about in some detail in the last video. The main operator is the one that has the widest scope. A simple rule for number 3, there's only one operator outside of parentheses, so that's the main operator. We're given truth values. O is true, M is true, N is false. We start inside parentheses. Disjunction. If we have a true and false disjunct, right, you can go back up to the disjunction truth table. True first disjunct, false second gives us a true sentence. So that means inside the parentheses we have a true sentence. Now we have a true antecedent and a true consequent. So again, if you go to conditional, true antecedent, true consequent gives you a true conditional. All right. And when you do homeworks like this, you should indicate the main operator, either with, you can do it with coloring it, you can do it with putting an asterisk over it like he does in the text, but you have to make it clear which operator is the main operator. All right, number 5. M is true, and again, these values are given at the top of the assignment. M is true. O is true, which means if we negate O, we get a false sentence, right? So I like to then cross off or eliminate these since it can get confusing to look. So now inside the parentheses we have a false antecedent and a false consequent, and we know that whenever the antecedent of a conditional is false, the whole conditional comes out true. So now this conditional is true, this disjunction is true, so the whole thing comes out as true. All right, number 7. We've got true, false, true, true. So we know this one is false because the conditional comes out false if we have true antecedent, false consequent, right? That's the only line where the conditional comes out false. But this one's true. So we have a disjunction, false or true, and we know as long as one disjunct is true, the whole thing comes out true. So again, that's the main operator. It's the only operator outside of parentheses. So 7 comes out true. N we know is false, so that means not N is true because the negation flips the truth value. So our antecedent here is true. Cross that off. Now, inside parentheses here we have T or T and if we have a conditional that has true, true, the whole conditional comes out as true. So inside the parentheses is true. So now we have true antecedent, true consequent, which makes the whole thing come out as true. Stupid thing. Oh, you gotta love Microsoft. Just gonna cross it off. Okay, so again, this was the main operator. Remember, if you have multiple operators outside of parentheses, there should only be one that's not a negation. In this case, we have negation conditional. So the one that's not the negation is the conditional. That's the main operator. All right, 11. So we have M is true, but negating it then gives us a false sentence. And then we know that if the antecedent's false, the whole conditional comes out true. So it doesn't really matter what N is, even though N is false, because we've got false conditional false, and false conditional false gives us a true sentence. All right, now we do the other parentheses. Again, not M is false because M is true. O is true. So again, a false antecedent gives us a true conditional. So now we've got true conditional and true conditional. So true and true gives us a true sentence. Again, the conjunction here is the only operator that's outside of parentheses. So that is the main operator. Okay, maybe get to even finish these for a change. All right, here we have N and not N, so false and true, but it's a conjunction, so both conjuncts have to be false, so that's false. Now notice anytime you have a sentence that has this form of N and not N, P and not P, Q and not Q, that's going to be false. That's what's called a contradiction. That comes up later in the chapter. Right? Because no sentence can be both true and false at the same time. So that's false. We've got a false antecedent, right? And we know that whenever we have a false antecedent, again, if you go look at the truth table for conditional, whenever the antecedent is false, the whole sentence comes out true. It doesn't matter what Q is. So in this case, we don't even really have to worry about what's in the consequent, because as soon as we discover that the antecedent is false, we know that the whole conditional comes out true. All right, and 15. Whoops. So 15. Oh, that's right. I'm in a different column. All right. Notice there's only one operator outside of parentheses. It's this negation. So everything else is inside the brackets. So we have to do all that stuff inside the brackets first, and then apply to the negation to it. So here we have true, false. We know that a conditional with a true antecedent and a false consequent is false. Inside these parentheses, we have not M. Since M is true, not M is false. And O is true. So that conjunction comes out false, since we have a false conjunct. But this negation over here negates that and gives us true. Now, if I was writing on paper, I'd be crossing all these T's and F's out as I finish, because as you can see, it gets kind of confusing to see which one goes where. But using the cross out function, well, you saw what happened. All right, almost finished. So now we've got false or true. That makes this thing inside the parentheses true, and then we